Alright, 2.3, let's talk about slopes. Students will be able to find and use the slope of a line and graph parallel and perpendicular lines. When we're talking about slope, we're talking about how steep a line slants. It's the ratio of the vertical rise, so how far up it goes, and the horizontal run, how far over it goes, between any 2 points. This is the generic formula we use. It's pretty simple. Do your second y minus your first y, second x minus your first x. So let's find the slope here. We can just mark these real quick. That's x1, y1, x2, y2. And let's just plug it in. So my y2 is -7 minus my y1, which is 2, over my x2, which is 4, minus -5. -7 minus -2 is -9. And when you have a double negative like this, it turns into a positive. So 4 plus 5 is 9. -9 divided by 9 is just -1. So that's it. That's the slope of the line. It's -1, or you could say -1 over 1, meaning that it goes down 1 over 1. Okay, I want you guys to try to find the slope of this next line. You're going to use the same formula. Here's your points. Plot them, see what you get. I'll put the answer up in just a second, so you may want to pause the video now. Okay, well, we did y2 minus y1, x1 minus, or x2 minus x1. We got 0 over 4, which is just 0. So we have a slope of 0. What does that mean? Well, that means it doesn't go up or down at all. It just goes straight right to left. And this is actually what that would kind of look like right here at y equals 1. Another thing you can check and see is if your y's don't change, then automatically the equation is just going to be y equals whatever that number is. Same thing about if your x's. Say if these x's were both 5s, then automatically it would just be x equals 5. Alright, let's go on to the next page. Okay, this one just says graph the line that goes through the point and has a slope of 2 over 3. So this is really easy. First, let's just plot the point. And I'm going to write down the slope here just for my own sake. But -4, -3 is right there. And then I'm going to go up 2 over 3, up 2 over 3, up 2 over 3. Easy. And there we go. I've graphed it. No problem. Real simple. Start at the point they tell me about and then just use the slope to figure out where to go. So why don't you guys try the next one. Remember the number on top is the rise and this is the run. So how far up or down does it go and how far left or right does it go starting at that point they give you. So go ahead and try this one and I'll put it up there in just a second. So you can pause the video now. Okay, if we go to 0, 3, 0, 3 is right here. The slope is -4 over 3. So that means I'm going to go down 4 over 3. And all you really need is 2 points. And that's enough to graph a line. If you can get it to, if you could draw it actually going through your point, unlike me. And that's really it. You just plot it and go. Use the slope to figure out where to go from there. Let's say you were to have different looking graphs, right? Let's say you have one that starts from the left and goes down. That's always going to be negative. Starts from the right and goes up. That's always going to be positive. Or sorry, starts from the left and goes up. It's always going to be positive. If it's just a straight line, that's 0 like we had before. And if it's ever straight up and down, that's undefined, okay? And it's actually not, it's not going to be a function. So, here's 6 examples real quick. All I want to know is, are these slopes positive, negative, 0, or undefined? You should be able to do that really quickly. So go ahead, pause the video, and I'll put the answers up in just a second. Okay, hopefully you got the first one is undefined. So I just wrote it as a circle with a line through it, just like no solution. This is going down, so it's a negative slope. Down, so negative. Up, so positive. Straight, so 0. And slightly up, so positive. So we should be able to recognize those types of slopes really quickly. We should be able to see what kind of slope we're going to get. So we should know, like if we work something out and we get a negative number for this slope, well, we know we did something wrong because it's going up. All right, let's go to the next page. All right, here in example number 8, they're asking us to calculate the rate of change. And rate of change is just kind of another way of saying slope. But if we look at our graph here, This is obviously not a straight line. It's kind of crooked. But that's okay. All we care about is the overall change from here to here, because we could kind of estimate the average change by calculating the total change from this point to this point. And look, our x values are years down here, so this is going to be my x value here. It's going to be my x value here. And these are my y values, 2.2 and 6.9. And what are they talking about? What do those numbers represent? They're millions. So let's think about this. If this, we could kind of go through and label this, right? So this 1985, that's like my x1, that's like my y1, and this is like my x2, and this is like my y2. Well, let's calculate the slope. y2 minus y1, right? So 6.9 minus 2.2 over 2,000 minus 1985. 6.9 minus 2.2 is 4.7. And 2,000 minus 1985 is 15. So over a 15-year period, we went up 4.7 million. More people are taking the cruises. Well, let's figure out what that means per year. 4.7 divided by 15, put that in your calculator. You're going to get something like 0.313333. All right. So what does that mean? Well, does that mean that there's 0.3 more people riding on a cruise every year? No, it doesn't, right? Because this graph is in millions. So if I was to take this 0.3 of a million, the actual answer would be 313,333 more people on cruises each year, or per year. And that's how you can do that one. Alright, let's talk about lines that are perpendicular and parallel. This is old stuff that we've done before. First of all, parallel lines. What do we know about parallel lines? Well, they always have the same slope. Parallel lines will never intersect, because they go right next to each other, right? Because parallel lines look like this, right? These guys keep going on and on forever side by side, and they never intersect. And they do not have the same y-intercept. Okay, if they had the same y-intercept, they'd be the same line. So they need to be two distinct lines. All right, let's talk about perpendicular. Well, what do we know about perpendicular lines? Well, we learned a long time ago that they have negative reciprocal slopes. What that means, remember, reciprocal is if you started with negative a over b, the reciprocal of that would be negative b over a, but we are going to change the sign, the negative of that. The negative of negative is a positive. So this is a reciprocal. We just switch it and change the sign. So that's how we find slopes. One's always going to be negative, one's always going to be positive. Also, if we multiply these slopes together of two perpendicular lines, they'll have a product of -1. So you could see that right here. If we were to multiply these two fractions together, the b's would cancel out, the a's would cancel out. All I'd have left is a -1. All right, and lastly, horizontal and vertical lines are always perpendicular. So if we ever get one line that's vertical, its perpendicular line is horizontal. Okay, so let's put this to practice. It says graph the line that goes through this point, -1, 3. All right, let's do that. First, let's just find that point. -1, +3. All right, there's that point. And let's see, what else do we know about this line? Well, it goes through that point, but it's parallel to this line. Now, I don't need to graph this line. I just need to know what the slope is of this line because, remember, parallel lines have the same slope. So I just need to find out the slope of this guy, and that'll be the slope of my line. So let's take a look. Well, let's see. We have an equation in standard form. Remember, the slope is equal to -a over b when it's in standard form. Well, negative, my a here is just a little imaginary 1 over b, which is 4. And it's parallel to this, so that's my slope as well, -1/4. So let's take a look. Come over to my graph. That means I go down 1 over 4, down 1 over 4. Connect these dots, and I've got a graph. Bam. Okay, let's try the next one though, because this one's a little bit different. Graph the line through -3, 1. Okay, let's plot that point. Go back 3, up 1. And this time they say it's perpendicular to this line. Okay, well that means whenever we find the slope of this line, we're going to have to flip it and change the sign. But let's find the slope of this guy first. We know that the slope is equal to -a over b. In this situation, my a is 2, my b is 5. But I don't need the same slope, I need the perpendicular slope. So I'm going to flip it. Put the 5 on top, the 2 on bottom, and change the sign. It was negative, so now it's positive. So this is the slope I'm using for my graph. So let's take a look. 5 over 2. There's my point. I go up 5 over 2. That also means that I could go down 5, back 2. It's the same way. And bam. There we go. We have graphed some lines that when all they gave us was a point and an equation that it was either parallel or perpendicular to.